The 25th element on the periodic table of elements is manganese. This is Norris Teaches Science with me, Mr. Norris. Today on this physical science edition video, we're going to talk about half-life. This is the second half of my nuclear chemistry videos. There's only two of them because we only cover a little bit about nuclear chemistry and physical science, but we do cover some of it. So your goal for today is I can solve half-life problems. All right, stop right here, pause the video, make sure you have a calculator ready with you because we are going to do math. And it's not the basic math where we're going to subtract some numbers. We're doing actual math today. And I'm sorry, if you don't like math, it's just going to happen. Physical science involves math. So what is half-life? It is the time required for half of a sample to decay away. And we do know some half-lives of some isotopes out there like carbon, uranium. We know their half-lives. So everything starts with a certain amount of carbon-14 in them. And over time, the carbon-14 decays away and decays away. And we kind of use half-lives to determine how old things are, especially like fossils. So let's do some half-life problems. Just jump right into it. This is how it is. All right. But when you know you're going to do a half-life problem, this right here, this when I'm boxing, I always write that and start filling it in so I can know where I'm at. All right. The problem says you have a 30-gram sample of radium 226. It has a half-life of 1,620 years. How many years will it take to only have 7.5 grams of uranium 226? So the start is how much did you start with? According to this, you started with 30 grams. And how much did you end with? According to this, you end with 7.5 grams. And the next thing from the up here we can get is how long one half-life is. One half-life is 1,620 years. This blank down here is the number of half-lives. How many half-lives pass between 30 grams and 7.5 grams? And that's what we're going to have to figure out first. But it's not the answer here. Remember, we want to know how many years it took. So the first thing you do, you take 30. And your hint here is half-life. What do you do to get half of 30? Well, you divide it by 2. If you divide it by 2, 30 divided by 2, you get 15. That's not close enough to 7.5. So we're going to divide again by 2. If you divide again, you get 7.5. And here, you're close enough to 7.5, you stop. Number of half-lives. How many times did you divide by 2? 1, 2. We did 2 half-lives. So now we can figure out the years. Once you have all this, you're going to focus on this right here. You're going to do 1,620 years, and you're going to multiply it by the number of half-lives that happen, which is 2. This is where a calculator would come in handy, so you do not have to do all the math by hand. 0, 4, 2, 3. 3,240 years is your answer. And I didn't do it right then. I have done it on paper beforehand before I did this video, just so you guys know why I did everything a little bit fast with the math. So let's do another problem. Pause real quick and see if you can figure this out on your own. Truly, pause it. Try it. I'm not joking. Try this. In my class, my students would have already been working on it right away because I would have called on them to do work. All right, I digress. Let's go over this. Hopefully you paused and you ignored my whole rambling there. All right, it says the half-life of carbon-14 is 5,730 years. So we can go ahead and place that down here. How long will it take to take a 12-gram sample, that's how much we start with, to get to 1.875 grams? So again, we're looking for a time. So the first thing we do, we take our start and we divide by 2 to get the first half. And that's 6. That's not close enough, so we divide again by half. And we get 3. That's not close enough either, so we divide again and we get 1.5. 1.5 is kind of close to 1.8. Now, it's not going to be perfect. We're not looking for perfect numbers with these. We're looking for estimates here. So we can stop here at 1.5. Number of half-lives. How many times did you divide by 2? 1, 2, 3. We did 3 times. Then we're going to take these numbers here. We're going to do 5,730. And we're going to multiply it by 3. When you do that, you should get the answer 17,190. And you always need to place a unit, and this is years. And that's how long it took to go from 12 grams to 1.85, 1.875. All right. The last thing about nuclear chemistry that we need to talk about is something called fission versus fusion. Fission is splitting the nucleus into two nuclei with smaller masses. I actually look at the word fission and I see that there's 2 S's in there, and so I know this is the splitting one. I'm splitting things because the result of 2 nuclei. Fission is only really going to occur in your large mass elements. And when this does happen, it produces energy. Fission is most likely is what we do in our nuclear power plants on Earth. All right, fusion is a process where 2 nuclei combine to form a larger mass. All right, I have one S in this word. That means that because let me start. There's one S in fusion reminds me that the end result is 1 nuclei. These are how I remember things. This is my study technique. It's something I've always done. Find connections between things. Now, fusion is only going to work in small mass nuclei, which means you're going to take your smaller mass stuff, the stuff near the top of the periodic table, and fusion does produce energy. It's one of the ways that stars, plasma, and the sun are produced. The sun makes all of its energy by fusion, and that energy is then transferred to Earth. But I hope you learned some stuff about nuclear chemistry in this video. If you haven't watched the other one about nuclear decay, go watch that. But for this video, Mr. Norris is out, and I'll see you at the next one.